Today, New Zealand's coastline is home to many animals. But if we look closely, we can also find traces of extinct animals that lived millions of years ago. Like these small and triangular teeth, which belonged to a dolphin. Its skull was found by scientists after many days of excavation. As you can see, many teeth are missing, but don't worry, they were found later around the rock. The ocean was also home to some large whales. These bones were found after digging 3 or 4 meters into a cliff. Big bones can be very impressive, but small teeth are a significant resource for scientists as well. Professor Dr. Ewan Fordyce is a paleontologist at the University of Otago who studies fossils, and he believes teeth are a key to understanding extinct animals.
There's one sort of fossil that most people will recognise straight away, and that is a fossil tooth. And the reason people can recognise it is it looks like a tooth. Why do these fossils look like teeth? They're made of very resistant minerals and they preserve really well, so they tend not to alter in the rock record. We can find fossil teeth and see exactly what they are. We can see their fine structure, we can see their shape, we can understand how those teeth might have worked. So teeth are very revealing about the animals from the past.
Perhaps you know this building. It's the Geology Museum at the University of Otago. Here you can see a block of more than 150 teeth from an extinct white shark that was much bigger and heavier than any living white shark today. The size of the teeth revealed that the animal was 9 meters long, and living white sharks only reach 6 meters. Have you seen a shell like this before? It looks the same as a living one, but it's 20 million years old. Let's see how it turned into a fossil.
What is a fossil and how does it form? A fossil will always be the part of some living organism, a tooth, a bone, a shell, maybe a leaf from a tree. We can imagine that that little part of some organism falls into water, and the water may have mud or sand beneath it, some sort of sediment. The fossil gets gradually covered up by more sediment that is coming in with the water, and eventually it will become buried. And we can imagine there's a big stack of sand or mud with bones or teeth or shells or leaves in, and it gets buried and squeezed together. And ultimately that becomes rock, so we have a fossil trapped in the rock.
Sometimes an organism can leave an impression in the rock, creating another type of fossil.
Let's imagine that we have a shell which is buried in mud, in the sea or in a lake or river. And that shell gradually gets turned into a fossil as it is covered by many meters of sediment buried beneath the earth. Sometimes the shell can dissolve. The fossil itself can actually dissolve to leave a cavity in the rock, and that cavity can become infilled by some sort of mineral, crystals, growing in the cavity. So that's a second way in which we can get fossils. We go from the original shell to a fossil, and then the fossil has dissolved and been replaced by some sort of mineral.
Isn't this rock beautiful? It's a natural mold. Inside the hole is the impression of the original specimen. Aren't we lucky to live in a country where the beach is just around the corner? Walking on the sand, we leave our footprints behind. They're an impression of where we went. And animals can leave their impression as a track. They are called trace fossils, another way that fossils can be formed. Teeth like this are unique evidence from the past, but they're very fragile. It's very easy to break one. That's why scientists have to make a copy or impression of the original fossil.
This tooth represents one single ancient whale from long ago. There's only one of these known in the world. In that case, the specimen becomes very important, the single specimen, and maybe we get concerned about possible damage or loss or breakdown of the material. Maybe we want to send copies of the specimen overseas for others to study. So we can actually make a little replica, an exact replica of parts of that fossil, and we can use those to study and we can use those to send overseas. This way we're sort of protecting the fossil and giving it a longer life.
The south of New Zealand has a rich record of fossils, most of which lived in the ocean. And a remarkable specimen like this penguin helps us to decipher ancient environments, to understand the history of life today.